Hey guys, what's up? So today we're going to be looking at the highest common factor and the lowest common multiple, okay? Also known as HCF, right? And the LCM, okay? Now, the two definitions are here. The highest common factor of a set of whole numbers is the largest positive integer that divides evenly into all numbers with zero remainder. For example, the set of numbers 18, 13, and 42, the highest common factor is 6. Okay, so let's just look at that same example. Okay, let's look at the highest common factor first, and then let's look at that same example. Okay, so the example would say something like find the HCF, right, of 18, 30, and 42. Okay, yeah, so that would be the question. Okay, so let's do that. So the first thing we have to do is find the factors of 18. Okay, and let's do that the way we normally do it, which is 1 times 18. So that's a factor. Can 2 be divided into 18? Right? Can 2 be divided into 18? Yes, it can, and without leaving a remainder. So you get 2 times 9, which would be 18. Also, can 3 go into 18? Yes, 3 times 6 would give you 18. Can 4 go into 18? No, it can't. Can 5? No. Can 6? Yes. 6 times 3 would give you 18, but you don't want to write 6 times 3 again because that would just be redundant. 9 can also go into 18, 9 times 2. So, right, so we're pretty much good. We don't need anything else. We can see that all these 6 numbers are the factors. So all we have to do now is take these 6 numbers and write them as the factors of 18. So the factors of 18 would be 1, 2, 3, right? Right, so the factors of 18 would be 1, 2, 3, 6, 9, and 18, right? So let me just remove that. And I'm going to write that as... okay, so these are the factors of 18, okay? Oh boy. All right, so these are the factors of 18, okay? So let's look at the next one, which would be 30. Let's do the same thing. 1 times 30 is both of these are factors, and then can 2 go into 30? Yes. 2 times 15 would give you 30. 3 times 10 would give you 30. 4, can 4 go into 30? No. Can 5? Yes. 5 times 6 would give you 30. And I don't think there's any more, right? 10 can go into 30. 8 can't go into 30. Right, so these are pretty much the factors here. And I'm going to do the same thing. We're going to write these out. So there would be... All right, so the factors of 30 would be 1, 2, 3, 5, 6, 10, 15, and 30. All right, so let's look at 42 now. All right, 42, we're going to do the same thing. Let's do it over here this time. So 42 is equal to 1 times 42, right? 2 can be divided by 42, so that would be 2 times 21, right? Would give us 42. And can 3 go into 42? Yeah, it can. 3 times 14 would give us 42. Can 4 go into 42? No. Can 5 go into it? No. 6? Yes, 6 can go into 42, right? 6 can go into 42 7 times, all right? And yeah, we're pretty much done here. Anytime you see these two numbers are the same here, so it's 1, 2, 3, 6 to 7, then 14, then you can see that we're done here. I don't think there's anything else that can go into 42 without leaving a remainder. So these are the factors, right? And let's just write them out. 1, 2, 3, 6, 7, 14, 21, and 42. Okay, so these are the factors. So now, since we have all the factors for these three, all we need to do is find the highest number out of all these factors. And if we look here, we can clearly see that 6 is the highest number out of all these factors. So the HCF, right, for 18, 30, and 42 is equal to 6, just like the example said. Okay, and this is the best way to do it. Write out all the factors and find the highest one for the set of numbers. Okay, and this is exactly how the questions are going to look. You're going to get two numbers and they're going to ask you find the highest factor, or they may give you three numbers and ask you to find the highest factor. And that's pretty much it, guys. Great, right? So let's move on to the lowest common multiple. All right, guys, so we're moving on to the lowest common multiple, right? And which we usually call the LCM, okay? So for the lowest common multiple, the lowest quantity that is a multiple of two or more given quantities, example 12 is the lowest common multiple of 2, 3, and 4, right? So it's the lowest quantity that is a multiple of two or more given numbers, okay? So that makes a lot of sense, okay? But what I'm gonna do here, I'm gonna write the lovely method, okay? Remember earlier I showed you a method earlier I showed you a method to find the prime factors, right? So that's the method we're actually gonna use here, okay? We're gonna use the same lovely method that we had earlier, right? And we're going to use the same lovely method that we use for prime factors to find the lowest common multiple, okay? So let's go through it. Let's use the same example there, right? Let's say we have 2, 3, and 4, right? And the question says find the LCM, okay? So what we could do is we could write out all the multiples for 2 and write out all the multiples for 3 and 4, but that method sucks. So we're going to use a lovely method, which is the same type of method that we're using for the prime factors. And I'm just going to show you. You draw a little table here pretty much, okay? And you're going to use this table to find the LCM, right? It's really interesting. I'm just going to show you. And we're going to write out the prime numbers here, 2, 3, 5, 7, 11, right? So let's write out the first prime numbers because we're going to use them to find the lowest common multiple, okay? Now, we're going to divide all of these by 2. We'll always start with 2, so we're going to say, can 2 go into all of these numbers, right? Okay, all right. So we're going to do the same. It's very similar to the lovely method. And the first thing we're going to do is we're going to check if 2 can go into any of these. So we'll always start with 2, right? So we're going to say, can 2 go into any of these numbers? Can 2 go into 2, or can 2 go into 3, or can 2 go into 4? Yes, it can. 2 can go into 2. It can't go into 3, but it can go into 2 and 4. Okay, so we're just going to put this 2 here, and we're going to divide what can be divided by 2 by 2. Okay, so you're going to end up with 1 here, and you're going to, the 3 would remain the same, and you're going to end up with 2 here. Okay, and then we're going to do the same thing. We're going to ask the same question. Can any of these numbers be divided by 2? Yes, this 2 can be divided by 2. So we're going to get 2, we're going to put that 2 here. 1 would remain the same, 3 would remain the same, and then this 2 would be divided by 2 and would become 1, right? Then the last thing we would say, can any of these numbers be divided by 2? Again, right? But no, none of these numbers can be divided by 2, so we'll move on to 3. Can any of these numbers be divided by 3? Yes, right? So we put a 3 there, and then this would end up finishing here at 1, 1, and 1, okay? So we'd be finished there. And in order to find the LCM for these numbers, all we have to do is multiply those three numbers, right? So all we have to do is multiply 2 by 2 by 3, and then we would end up with 4 times 3, which is 12. So 12 is the LCM of 2, 3, and 4, right? Really nice, really amazing, okay? So let's do another example like this with the same method, okay? All right, so let's look at another question, okay? Let's say we have three numbers, okay? 12, 9, and 6, okay? And the question says, find the LCM for these numbers, okay? All right, so we're gonna use the same method, right? All right, so we're gonna write out the numbers 12, 9, and 6, and we're gonna draw this table, okay? Let's just draw this table. And then we're gonna write out the prime factors. We're gonna just write out the early prime numbers 2, 3, 5, 7, and 11, okay? So we're gonna start off the same way. Can any of these numbers be divided by 2? Yes, 12 and 6 can be divided by 2. So we're gonna divide those numbers by 2. We're gonna get 6 here, we're gonna get 3 here, and then 9 would remain the same, okay? Then we do the same thing. Can any of these numbers be divided by 2? Yes, 6 can be divided by 2. So we're gonna draw a line, and then we're gonna divide that 6 by 2. We're gonna get 3. These numbers would remain the same, 9 and 3. Then we're gonna do the same thing here again. Can any of these numbers be divided by 2? No. All right, so we're gonna move on to 3. Can any of these numbers be divided by 3? Yes, all three of them can be divided by 3. So we're gonna divide all three of them. Then we're gonna get 1, 3, and 1, okay? Then we're gonna start again. Can any of these numbers be divided by 2? No. But can any of these numbers be divided by 3? Yes. So we're going to divide by 3, and then we're gonna get 1, 1, 1. And you should always finish with 1, 1, 1 here, okay? Okay, so to find the LCM, all we have to do is find 2 times 2 times 3 times 3. So we would get 4 times 3, which would be 12, and then 3 times 12, which would be 36, okay? And that's the answer, all right, guys? So let's do one more. Let's do a difficult one, all right? Let's do like a really big one. All right, guys, so we're gonna look at this example. We're gonna use 9, 15, and 28, okay? So we should get a big number for the LCM here. And we're gonna do the same thing. We're gonna draw up the table, right? 9, 15, 28, okay? Let's draw the table, all right? And we're gonna use the same method, all right, guys? We're gonna start off saying, can any of these numbers be divided by 2, okay? And yes, they can. 28 can be divided by 2. That's the only number. So we're going to draw a line, and we're going to get 14, 15. These numbers remain the same, 15 and 9, right? Then we say the same thing. Can any of these numbers be divided by 2? Yes, 14 can be divided by 2. So we're going to get 2 again, and we divide here, and we get 7, 15, and 9 remain the same. Then we're going to continue, and we say, can any of these numbers be divided by 2? No. Then we move on to 3. Can any of these numbers be divided by 3? Yes. 3 can go into 9, and 3 can go into 15. So we're going to get 3, 5, and 7. Okay. Then we're going to start off here. Can any of these numbers be divided by 2? No. Can any of these numbers be divided by 3? Yes. 3 can be divided by 3, so we're going to get 3 here. Then we're going to draw a line. We're going to get 1, 5, and 7 remain the same. Okay, so we're going to start here again. Can any of these numbers be divided by 2? No. Can any of these numbers be divided by 3? No. Can any of these numbers be divided by 5? Yes. Okay, so we're going to have a 5 here. Then we'll draw a line. And we're going to get 1, 1, and 7. Then we're going to do the same thing here. Can any of these numbers be divided by 2? No. 3? No. 5? No. 7? Yes. All right, and 7 is a prime number, so 7 is here, and we're going to draw a line. Then we're going to finish here at 1, 1, and 1. Okay, so for the LCM, it's going to be 2 times 2 times 3 times 3 times 5 times 7. Okay, and that should give you the answer. All right, so this 2 times 2 should give us 4. 4 times 3 should give us 12. 12 times 3 should give us 36. 36 times 5 would give us, right, 180. And then 180 times 7 would be 0. All right, so the answer would be 1260. That's the lowest common multiple for 9, 15, and 28. Okay. All right, guys, so we're pretty much finished here for this video, and you should definitely understand this now, and eventually we'll do some examples. And thank you so much for your time. All right, guys, so that's it, and I'll see you in the next lecture, and remember to do your best, and God will do the rest.